Let's do some warm-up problems that you can do with your group, please. Sine 2 pi over 3. Cosine 5 pi over 4. Do it. Tangent negative pi over 3.
You said as a group, right? Or like by ourselves?
Yeah, with your partner. And let's do cosecant. Yes.
So I actually don't know.
All right. In a few weeks, you should have been done by now.
I should have been done.
Yes.
That fast?
Yeah, in your head.
10 seconds.
10 seconds, literally.
Wow. Wait, so how do you solve all these?
I promise you guys, some of you guys will be that fast in a few weeks. So you do this using the unit circle, right?
Yeah.
Start with the unit circle and then find the coordinates of the respective point that you've discovered on that circle. And cosine will be the which coordinate? The x coordinate, right? And sine will be the y coordinate.
That's the God. Wait, it's wait, 2, 3, 5, 120. So what? 2 pi over 3.
Oh, well, that angle is.
Wait, the measurements are 1/2 and then what is it? 3 something?
Square root and then the
I don't know.
Yes or not?
Yeah.
What are like the universal measurements for a 36 magnitude? Like what
1, 1/2, and root 3 over 2.
Is the first one is root 3 over 2. Root 3 over 2. Locked. 60. Beyond locked. That's opposite. You said root 3 over 2, right? That's the measurement opposite of this.
All right, who has them all? Good. Who has the first one? Everybody? Almost? Maybe? No? Any questions so far?
For the first one, Mr. Nye, how do we know it's root 3 over 2 and not negative 1 over 2?
Because the sine is always the y coordinate, right? Remember, cosine is the x coordinate. So this would be cosine, and this is going to be sine.
So sine is always y?
Mm-hmm. Right? We
Where's
remembered
tan?
tangent is sine over cosine, so we'd have to find both of them and then divide them. Right? Cosine is always the x coordinate because, right, c comes before s, so cosine is x, and sine is the y coordinate. So after we've found the coordinates of this point, 2 pi over 3, we have the y coordinate is root 3 over 2, so that's the sine value. Okay? Any questions about anything else in that problem? Okay, well, in the second one, cosine 5 pi over 4, right, 5 pi over 4 is just pi plus pi over 4, So we know that we're 45 degrees past 180. So that places us at this point here. And we know that's a 45, 45, 90 triangle, so it's going to be root 2 over 2 and root 2 over 2. And they're both negative because they're in that quadrant. And then it's a cosine, so we want the x value, which is negative root 2 over 2. So that's our answer. Questions? Sure.
Is it the same?
Well, tangent negative pi over 3. So that's negative 60 degrees, so we're going to go clockwise, starting from 0. And the coordinates are going to be 1/2, comma, negative root 3 over 2.
Wait, do you like draw it out?
The triangle?
Yeah.
Sure. This is 60.
Well, why wouldn't you like draw it the other way?
Huh? You can draw either way you want. So this length is 1, and this is 1/2, and this is root 3 over 2. Okay? So that means that sine of negative pi over 3 is equal to the y value, which is negative root 3 over 2. And cosine is positive half, because it's the x value. And then tangent is sine over cosine. So that means we're left with negative root 3 over 2 divided by positive 1/2, which is negative root 3. Okay, this is just a review of the homework, which you guys all did. Maybe. Okay, questions about tangent? All right, cosecant. Cosecant is 1 over sine, right? Well, this is the same point we just found. So that's 1/2 and negative root 3 over 2. And cosecant is 1 over sine, so we're going to take the reciprocal of the y value. So that's 1 over negative root 3 over 2, which is equal to negative 2 over root 3. And then we rationalize that to be negative 2 root 3 over 3, which is our answer.
Wait, so this is like the first like 6 problems of practice quiz that you gave us?
Yeah. Or no, it's different from the previous quiz.
No, the practice one. The sample one that you gave us?
That's posted on Moodle.
No, sorry.
I don't know what sample quiz you're talking about. Matthew?
No? You posted the sample quiz online.
I did. Yes, so this is what will be the first 10 questions on the quiz coming up next class.
They're not easy.
Yes, it is. Any questions? All right, we're moving on. Either this is too easy or too hard. Next one, do by yourself. Cotangent of 5 pi, please. This one's a little tricky because it's bigger than 2 pi, right? So we're going to have to start by subtracting a multiple of 2 pi from the 5 pi, which doesn't change the value of cotangent because it returns us to the same point on the unit circle when we subtract a multiple of 2 pi, which was the subject of our previous lecture. Anybody got it? Yep.
How do you know it's a so there's 60 left essentially.
All right, I'll go over it.
Is that here? Or undefined?
Undefined. Well, 5 pi is the same angle as pi, because I can subtract a multiple of 2 pi, in this case 4 pi, and I'll get pi. So that places me at this point right here, and the coordinates are -1, 0. Well, cotangent is just 1 over tangent, so that's cosine over sine. So that's cosine pi over sine pi, which is -1 over 0. which is undefined. Questions? No questions?
Yeah, the other question.
Yes.
Can you repeat like cosecant? Like, you know how like cotangent is cosine pi over sine pi? What's that for cosecant?
Cosecant is 1 over sine.
What?
1 over sine.
Oh.
All right, let's go on to proving a trig identity. Trig identity. If you're confused, watch the video later. 1 over cosine squared theta equals cosecant squared theta. This will be on the quiz as well. Worth 5 points? 10 points? I forgot. 5 points. Yeah. So here we want to use the identities that we know, like sine squared plus cosine squared equals 1, tangent equals sine over cosine. Okay. So here I might want to start by using this identity somewhere. And then a general other good first step is to rewrite everything in terms of sine and cosine. So cosecant is 1 over sine. Mm-hmm.
After you do wait, cosecant.
Okay. Well, first step is probably noticing that 1 minus cosine squared is equal to sine squared. That's just from this expression here, this equation. All I did was I subtracted cosine squared from both sides for that Pythagorean identity, which tells me that 1 minus cosine squared is sine squared. So I can plug that in here for my left-hand side. The left side is 1 over sine squared. And the right side is also 1 over sine squared, right? Because cosecant is 1 over sine. So I'm done. Left side is equal to the right side.
Could I just turn the left side into cosecant squared instead of that?
That would not be solving the problem.
No, I mean for the last step. Could I just?
Oh, okay, yeah, sure. Questions? All right, next question. This one is probably one of the hardest questions on the test, in my opinion. The quiz, sorry. It's basically a test. I'll just call it a test.
Quiz. Not like questions, but like how long will it take us?
40 minutes are allotted for the quiz.
Wait, depending on like how long I pace, we get extra time if like all done.
No.
So like, if we're all not done, we're gonna cheer.
If you're all not done, I'll curve it, right? But I want it to be fair between the periods, right?
So then you can just give every period.
That's easy.
What's this?
Oh yeah.
This is very similar to the last question on the homework, right? Which you guys all did so diligently.
What's your homework journal, Mr. Mac? What's your homework journal?
What's a homework journal? It's where you show your work. So that's due at the Let's do next class, actually.
Next class?
Yeah.
Mike. What if I keep scrapping?
Then you'll get a 0 on it.
That is good. Might have to go back and do all the work.
What?
Like, what's whatever we're doing right now?
Yes. There's a reason I'm doing every single question. So I've posted a practice quiz online. The real quiz will be the exact same order of questions in the same type of questions, pretty much with numbers changed
Where is it online?
on where it's usually at.
How many questions are there?
I think 6. But one of them has like 10 parts, so I don't know if that counts as. It's 50 points if that helps.
Oh, it's 50 points. How many questions?
I just said 6.
The quiz?
Yes.
Oh. Okay, I thought you said 50.
Question 1 is 20 points. It's basically evaluating 10 trig functions, so 2 points each.
Chapter 4, quiz 2 practice test.
And I've also posted the key for that, and I've also solved it in a video on YouTube. And I've posted extra practice problems, which are very similar to the quiz problems, but more of them. All right, who has cosine theta?
-4.
Good. How do we get that? I'll do the work in maybe blue. Okay, guys, question 1, part A. Cosine theta, you're going to want to find that using Pythagorean identity.
Are you pre-recording?
Yes. Right, as we just learned, cosine squared equals 1 minus sine squared. And you can calculate this yourself. But 1 minus sine squared is 16 over 25. Okay, so that means cosine theta is equal to plus or minus 4 over 5. We don't know whether it's plus or minus because it could be either. But the fact that it's in quadrant 2 tells us that it's negative. Okay? Because anything in quadrant 2 has a negative x value, is that right? And so the cosine, which is the x value, must be negative. So the answer is negative 4/5. Make sense? I just calculated it. I didn't have space to show it. So it's 1 minus 9 over 25, right? Okay. Review that later if you're confused. Sine of negative theta. Here I'm going to use the fact that sine is an odd function. So sine of negative theta is negative sine theta, which is negative 3/5. Okay? If you're confused, what you could also do is simply observe that, if my point was here and this was theta, then this point is negative theta, right? And so that's just flipping the y coordinate, which means that sine becomes negative when we put in a negative theta. Questions? I feel like nobody's listening.
I am.
Okay. Maybe it's just Ruhan talking. Are you sure? Ruhan, what's the answer to part C? You're just distracted. It is, no, it's 3 over 5.
Oh, 3 or 5.
That's because pi minus theta is a reflection across the y-axis. So if theta is here, then this is pi minus theta. You could also do this algebraically. Sine of pi minus theta is equal to negative pi minus theta. I'll do it out a little more. This is equal to pi minus theta minus 2 pi, right? Because subtracting 2 pi doesn't change anything. Which is equal to sine of minus pi minus theta, which is equal to negative of sine of pi plus theta, which is equal to negative of negative sine of theta, which is equal to sine of theta. I know that was tricky. I'm not going to put a pi minus theta on the test, by the way, but it's on the practice quiz.
I'm not gonna put a what?
I'm not going to put a pi minus theta onto the quiz, but it is on the practice quiz, so just be aware of that.
What about pi plus theta?
That will be on the quiz, because that's a lot easier to think about. Okay, next one, theta plus pi. Who has the answer? Very good, negative 3/5. The reason is because if theta is here, then adding pi simply takes us 180 around the circle, right? So that's going to be flipping both the x and the y coordinates. So this is equal to negative sine theta, which is equal to negative 3/5. As I said, these are one of the harder questions on the test.
These ones are,
Huh?
both of those aren't gonna be on the test, or quiz.
This will. This is on the quiz, 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 and this is on the quiz. No, the quadrant will be different, and the exact number will be different.
Okay.
But what I'm talking about is that will be on the quiz. This also might be replaced with cosine.
Okay.
Take a look at the extra practice problems if you want to know what the quiz question will be like. Oops. All right, who has the answer to part E? Wrong. Very good. Here we just use the cofunction relationship that we derived in the first lecture. Okay, as we recall, cofunctions of complementary angles are equal. So pi over 2 minus theta is simply the complementary angle of theta. So that's equal to sine theta, which means that the answer is 3/5. Finally, anybody who has part F? Part F? Yes, this is just 3/5. Because adding 2 pi to the argument of sine does not change the value, because it has a period of 2 pi. So that's equal to sine theta, which is 3/5.
So why is it 3/5?
It's from our first lecture. Cofunctions of complementary angles are equal to each other. So cosine of pi over 2 minus theta is equal to sine theta. Questions? All right, study hard for this. Yep, this is a hard question. I have a lot more left. This requires just a lot of understanding of how the unit circle works, right? So that's why it's a little tricky. It's next class. It's at the end of next class if that helps, so we'll have 30 minutes to review.
30 minutes to review what?
At the beginning of next class.
So before the quiz?
Mm-hmm. I can answer any, yeah, Ayla.
How is cosine pi over 2 minus theta?
We derived that in the first lecture. Mm-hmm. First lecture, maybe second lecture, something like that. But those were the relationships between cofunctions, if you remember. So, right, cosecant of pi over 2 minus theta is equal to secant theta. Cotangent of pi over 2 minus theta is tangent theta. All right, next question. Thankfully, this is being recorded.
Could I take a picture of,
You can go look at the video later.
oh,
Okay, next one, which will also appear in the quiz and your homework, is questions like these. If sine theta is less than 0, let's do greater than 0. If sine theta is greater than 0, and cosine theta is less than 0, then which quadrant is theta in? Correct? Yes. Yes. Okay. So these are not too hard. These are pretty easy, right? The idea is that, on the unit circle, if sine theta is greater than 0, then that means the y coordinate must be greater than 0, right? And if the cosine is negative, then that means the x coordinate must be negative. So basically, we're just looking for which quadrant are these two conditions satisfied. I don't really like that mnemonic. I prefer logic instead. Because, some people use that, all students take calculus thing, and then they just mix it up, and they get everything wrong. But if you actually know why it works, you'll get it right every single time.
But you have to figure it out like every time. You use all students take calculus as fast.
No.
Like you can know the logic and use all students take calculus.
All right, so y is greater than 0 in these two quadrants, and x is less than 0 in these two quadrants. So that means the answer is quadrant 2. Any questions? All right, I'll give you guys another one to do by yourselves. If cosecant of theta is less than 0 and secant of theta is greater than 0, then where is theta? Cosecant of theta less than 0 and secant theta greater than 0. 4? I agree.
Is a question like this gonna be on the quiz?
Yes.
Just one?
2. 2.5 points each.
Yeah, because the sine and cosecant are the same sign.
Okay, if cosecant is negative, then that means sine is also negative, right? Because cosecant is the reciprocal of sine. So if cosecant is negative, sine is negative. Likewise, cosine must be positive, which means that y is less than 0 and x is greater than 0. By the way, if you use the all students take calculus thing, that will be considered not showing work. Because you're not using logic. You're not demonstrating that you understand the question at all.
But if I actually memorized everything without using all students take calculus. Because I just when I look at it, I pretty much know it.
No. Show some work. Okay, and then if y is less than 0, then that means we must be in these two quadrants. And if x is greater than 0, we must be in these two quadrants. So we're in quadrant 4.
Would that be that question be considered showing work?
Yes, my solution is considered showing work. Questions? Okay, tangent is a little more tricky, right? So let's say we have tangent theta is greater than 0 and sine theta is less than 0. All right, which quadrant would it be in?
Third, fourth.
Looks like your strategy doesn't work. 3, that's right. Okay, tangent is a little more complicated because in order for tangent to be greater than 0, that means that sine over cosine must be greater than 0. That tells us that sine and cosine must have the same sign. They must either both be positive or they must both be negative. So there are two cases. One is that sine is greater than 0 and cosine is greater than 0, or they're both negative. Because only a positive number divided by a positive number will give a positive number, or a negative number divided by a negative number. They can't be opposite signs. So that tells us that either y is greater than 0 and x is greater than 0, or they're both negative. So only quadrant 1 and quadrant 3 are possible for tangent to be greater than 0. Okay, so we can draw that.
Appreciate you, man.
And if, the final condition is that if sine is less than 0, then that means that the y value must be less than 0. So this is our red condition and this is our blue condition. Then if we draw the axes, then in order for tangent to be greater than 0, we must be here or here. In order for sine to be less than 0, then we must be here. So the answer is quadrant 3. Okay. More tricky. Any questions? Very logical, right? This reminds me of those puzzles where it's like, oh, Alice is in square A and B, Bob is not in square C. I don't know. You guys know what I'm talking about?
Yeah, we're
Yeah,
fine.
yeah. I'll let you guys do a practice question. Let's say cotangent of theta is less than 0 and secant of theta is less than 0. Find the quadrant. Who has the answer? Looks like your all students take calculus doesn't work so well, huh?
I wasn't paying attention.
Is it the second?
Yeah, second quadrant.
Is it four?
No, it's second.
Two.
Yes, after 20 seconds.
Because I thought cotangent, like it would have like swapped it.
Is one of
All right, cotangent is cosine over sine, right? So that means that cosine and sine must have opposite signs. One must be negative and the other must be positive. Okay, so if this is a red condition, then that means cosine and sine must have opposite signs, which means y and x must have opposite signs. So we're either here or here. Now, if secant theta is less than 0, then that means cosine theta is less than 0, which means that the x value is less than 0. So we're in one of these two quadrants. So the answer is quadrant 2. What? Today's technically new content. So this is a question that is new, I guess. So, but it's preparing you guys for the quiz. This will be question 5 on the quiz.
Question 5.
Yeah, some variation of this. There will be 2 of these for question 5. Any questions? I'm so hungry. All right. Last class of questions, which will be question 6 on the quiz. Find 2 solutions theta where 0 is less than or equal to theta, which is less than or equal to 2 pi. So theta is between 0 and 2 pi, such that, let's say sine theta equals 1/2. So find 2 solutions for theta here. How would you guys do this?
What ST meaning?
Such that it's a shorthand that mathematicians use sometimes. Like ST, W log, without loss of generality. I don't know, random facts. Or WRT with respect to. Anybody have the answer?
Pi over 3.
No.
Pi over 6.
Nope. Nice try.
Oh, wait.
Okay, basically, we're looking for 2 points on the unit circle that have a y-coordinate of 1/2.
I got it.
Alexandra?
Pi over 6 and pi over 5.
Very good.
And then do I need degrees too?
Huh?
Do I do degrees as well?
No. I specifically want theta in radians, right? So, very good. Pi over 6 and 5 pi over 6. Let me explain that. So, if sine theta is equal to 1/2, then that means we're looking for a point that has y-coordinate 1/2 on our unit circle. So we can draw that here. 1/2 is right here. So we're basically looking for these 2 points. 2 points that are on this line that have y-coordinate 1/2. So that's this point and this point, and you can kind of tell by eye that this is pi over 6 and 5 pi over 6. Right, because this one is pi minus pi over 6, so that's 5 pi over 6. Got it? Not guess, but just know. If you really wanted to, you could draw out a right triangle. I mean, 1, and then you know this is 1/2, because it has y-coordinate 1/2. So that tells you that this is 30. Okay? But for showing work on the quiz, I'm happy with you just drawing a circle with these 2 points and maybe a line. This line would be good to show too. Okay?
Can you do another example?
Yes, you can do it by yourself. Let's do cosine theta equals 1/2 this time. And you're looking for theta between 0 and 2 pi. Okay, very important. If it's not between 0 and 2 pi, but it's still correct, you might lose a small amount of points. Yep, so we're looking for x-coordinate 1/2 now. So you might be helped if you draw a line through x equals 1/2. Think about where those 2 points are.
I don't know what that is.
Answer? Anybody?
5 pi over 3.
Good. That's one of them.
5 pi over what?
5 pi over 3?
Is this pi over 3?
Yeah, pi over 3. Okay, we're going to draw our circle, and we're looking for 2 points that have x-coordinate 1/2. So those are anything along this line. So that's these 2 points. This one is pi over 3, and this one is 2 pi minus pi over 3, right? Because it's like we're going all the way to 2 pi, and then we're going pi over 3 backwards. So that's 5 pi over 3.
Hey, where do you get the line from?
The x value has to be 1/2. The x coordinate has to be 1/2. So I drew a line through 1/2.
Is it because cosine is needed?
Yes. Next one.
That's kind of like seeing like, I memorize like a song that has like a song.
Find 2 values of theta between 0 and 2 pi, please. Who has the answer?
1 over 3 pi.
Nope. Nope.
Oh.
5 over 3.
No. No. By the end of this unit, you guys will be able to do it in 2 seconds in your head. Maybe. Honestly, maybe not. Good, that's one of them. Very good. 5 pi over 6 and 7 pi over 6. Okay. We're going to draw a unit circle, and we're looking for 2 points with x-coordinate negative root 3 over 2. Negative root 3 over 2 is really close to negative 1, right? It's like negative 0.87. So that's somewhere around here. And so we're looking for these 2 points. Right? And those are just pi over 6 around pi. So the top one is pi minus pi over 6, which is 5 pi over 6. And the bottom one is pi plus pi over 6, which is 7 pi over 6. And that is our answer. Questions? Anybody need more time on this slide? Next slide. Tangent is a little harder, isn't it? Because that tangent doesn't correspond to an actual coordinate. So let's say we had tangent theta equals 1. Okay? Now, for when we have tangent, we have to basically kind of almost guess what sine and cosine are, right? Not guess, but like just know. I don't know. So when tangent theta equals 1, then that means sine and cosine are the same, right? Because tangent is equal to sine over cosine. And sine and cosine are only going to be the same if they're both equal to plus or minus root 2 over 2. So these are the only two possibilities for sine and cosine to be the same. Okay? So we're looking for these 2 points where sine and cosine are the same. And that can only happen if they're both equal to plus or minus root 2 over 2. So we're basically just looking for these 2 points on the unit circle. And that'll give us our answer. So that's either here or here. Pi over 4 and 5 pi over 4. Questions?
I'm so good.
How do you know it's root 2 over 2?
Because that's the only value for sine and cosine where they'll be the same. Okay? So you can think about it. X and Y are only going to be the same when we have a 45, 45, 90 triangle, right? Because that's the only isosceles one. So that will give us 1 and root 2 over 2. And same for the x value. And we also have to include the negative version, right? Okay. Tangent is tricky for sure. Let's do another example of tangent. This time, let's do tangent theta equals root 3, which is the other possibility. Root 3 or 1 over root 3 sometimes. Okay? Tangent theta will only equal root 3 when sine theta equals root 3 over 2 and cosine theta equals 1/2. Okay? You can confirm that sine and cosine divided by each other will give us root 3. And we also have to include the negative case, right? So sine theta equals negative root 3 over 2, and cosine theta equals negative 1/2. Okay? You can confirm that both of these cases will give us tangent equals root 3. So we can find that on our unit circle. That's going to correspond to these 2 points. This point and this point, which is pi over 3 and 4 pi over 3. Definitely a tricky question.
We're not gonna have anything.
You will.
Like, until the test.
No, it'll be on the quiz. All right. I would really study hard these next few days. Any questions? All right, Mia? Mm-hmm. All right, you guys try one yourself. See if you can get it. Tangent theta equals negative root 3 over 3. Not an easy one. But a hint, negative root 3 over 3 is just negative 1 over root 3, right? So maybe that will help you. So you need to try to think about which values of sine and cosine will give you negative 1 over root 3 as your tangent value. Anybody have the answer? I don't know. Maybe I'm not showing you guys the best way. I do it using a trick in my head. I don't know if I want to show you the trick. Nope. Tangent pi over 2 is actually undefined. Anybody got it? Mm-hmm. 5 pi over 6. It's one of them. Very good. Yep, 11 pi over 6. Very good. Definitely a tricky one. I'll show you guys. Okay, tangent theta will only equal negative 1 over 3 in these two cases. So sine and cosine definitely have to be opposite sides, right? One has to be positive and one has to be negative. And because we have the 1 on top, that tells us that sine will be 1/2 or negative 1/2. And because the root 3 is on the bottom, then that tells us that the cosine will be negative root 3 over 2. And then we also have to consider the case where the signs are flipped, right? So that's negative 1/2 and positive root 3 over 2. And so we're looking for two coordinates that look like this. And on the unit circle, that's just this point and this point, which is 5 pi over 6 and 11 pi over 6. Any questions? I probably gotta stop right here.